We are interested in studying dyes because we want to know how to make products with artificial dyes such as Gatorade like the store brands do. We are interested in studying the blue number 1 dye present in Gatorade Blue Glacier. The blue number 1 dye contains 3 benzene rings attached to a central carbon known as triaromethane, which is a chromophore that makes the blue number 1 dye have a blue color. Our independent variable in our experiment is the amount of our substance we will use and how diluted the substance will be that we put in the cuvette. Our dependent variable in our experiment is the absorbency that each of our cuvette substances records. One control that we have is our first cuvette will be distilled water to calibrate the calorimeter.
Our hypothesis is that going to be 2.5 milligrams per milliliter of blue number 1 dye in a simple serving of Gatorade Blue Glacier because it appears dark, which makes us think it has a high concentration of blue number 1 dye.
You are going to need distilled water, blue number 1 dye, a calorimeter, a pipette, 7 cuvettes for dye and 1 for the distilled water, Kim wipes, blue glacier Gatorade, and a computer for the graph. After getting all your supplies, connect your cable and calorimeter to the computer and open up the Logger Pro 3 program. Then set your calorimeter to a 635 nanometer wavelength. Place the cuvette of distilled water into the calorimeter and press the blue cal button. Your absorbance on the computer screen should be at 0.00. Push start on the screen to begin collecting. Place each cuvette into the calorimeter. Press keep and enter with the appropriate concentration. After you've entered all 6 data points, push the stop button. This is our data table showing the concentration and absorbance of our samples of the blue number 1 dye that we used and the real Gatorade that we used. As you can see, the absorbance and the concentration of the blue Gatorade to the blue number 1 dye samples were not even close, and we will explain that in our conclusion.
After our experiment, we calculated our percent error and it was 80%, which is not good. After our experiment, the accepted value for blue number 1 dye was 0.00 milligrams per milliliters. We got 0.0002 milligrams per milliliters. In our hypothesis, we estimated there would be 2.5 milligrams per milliliters, and we were off by a lot. A systematic error we encountered was that our calorimeter was not as good as we needed to be to get the proper results, and that's why our percent error was so bad and so high. A random error that we could have pressed the keep button on the computer before the calorimeter was done reading the cuvette that we put in. What we learned was not really that important because the accepted value was already online and we didn't have the proper equipment to get very good results. But in saying that, I would love to do this experiment with the right equipment and with my partner Gabi.